Hello and welcome back. I'm going to show you some more information here about wrangles and how they can be used. If you haven't watched the introduction lecture on the wrangles, you should probably check that out first just so you have the foundational knowledge you need to follow along in this one. We're not going to go over anything too crazy in this, it's all just fairly basic stuff just to get you up and running with wrangles. So let me show you what we're going to do here. We're going to make a cool little star shape based out of points and lines, and we're going to make it procedural, so you can apply it to just about anything. Open up a session of Houdini if you don't have one open, and just hit tab and type in grid. Double click to dive into it. Let's back our view out a little bit here. And now let's just drop down a scatter node. Plug it in. We're just going to scatter a bunch of points here. Now, this is maybe a little too many, or I don't like this very uniform arrangement, so let's do something about that. By default, it has this relax iterations on. You can disable that. Now you can see it's much more sporadic and natural. Let's disable our grid here. You can see the difference now. That's how it is by default, which I don't really like. Sometimes you actually want to use this, but most of the time you want to disable this. Now let's Alt and left drag this over. So we create a copy, and now let's make this one have a lot fewer points. Let's only go, say, with 20 points here. And you can adjust your global seed a little bit. It just scatters them in a different arrangement. Now let's drop down a group node. Plug in. And let's change this to points. And we will call these, let's call these the target points. And now Alt and drag this over and wire it in like this. And we're going to change this name to source points. You might be able to have an idea of what we're going to do here. These are going to be source points, obviously, they're named source. And we're going to just look at all these surrounding points and then randomly draw some star lines out to them. And by star lines, I mean just a straight line is going to go from this source point to a point out here, and it's just going to do that all over the place. I'll show you what I mean. It's pretty simple. Alright, let's go with a merge. We're going to get these points together so they look like they're part of the same geometry. It'll make it easier to work with them in our wrangle. And of course, we're going to drop down a wrangle since that's the focus of all these videos. Cool things you can do with the wrangle node. So first things first, we are only going to want to work on our source points. We're going to use these as our sources, so we don't want to run over all the points. That's why we created this source group up here. And we're going to use something called the near points function. So this is going to return an array. You can actually start to type it. And you'll see a little description here of what it's going to do. It's going to... Now, it's spelled a little incorrectly, or their grammar here isn't exactly correct. It says finds all the closest points in a geometry. Just omit this the. It finds all the closest points in a geometry. And it's going to ask for geometry, which you should know by now. That's just going to be which input of this wrangle node we want to use. And we're going to want to use the 0 input, the first input. Vector PT is just going to be the P value, our current position. And then a float max dist. And you can even add a maximum point. So if you want to limit how this much searches around that source point, you can give it a maximum distance and how many points you want it to be able to find. If you only wanted it to, say, return the 3 closest points, you could put a 3 there, or whatever. You get the idea. It gives you information down here if you want to read through it all. So we can do 0, P, and our max distance. Let's just start with, say, 0.1. Now we have to assign this to an actual variable, so do an I. And you got to put your little bracket symbol here, and then at. And we can just call it NP to mean near points, space and equals. Now this is in Houdini how you initialize your array variable here. You give it before the variable name. In a lot of programming languages, you would do it after. But if you look up here in our geometry spreadsheet, you can see the NP has been created. Currently it's empty. Let's check out why. If we go up here and sort this, let's see if there's actually, okay, so here we go. The reason why it appeared to be empty is because we have to remember that we are only running this code on our source points. You can see right here. So by doing that, it's not going to actually populate this NP attribute or this variable on any of the points that aren't our source points. It's only going to do it on our source points. And if I recall, we had 20 source points, and right here we have 20 points. So that is why. And you can see our distance here isn't large enough because a lot of them are only getting 1 point. Some of them are getting no points, even though they will look like they have a point. If you notice, this point number is 1000. The first point that is returned in our near points function is in fact 1000, the current point that it's on, and that's like it for every single point. Okay, so what it's doing is, even though this is running on, say, point 1000, this near points function is going to say return all the closest points to the position of that point, including the point itself. It doesn't omit the point that it's currently on, so that'll always be added into your array of returned points, which you typically don't want to actually use that point since that's the point you're currently on. So we're probably going to have to modify this. It's going to be something you're going to be modifying throughout this whole thing. Now you see with a 0.25, you get a lot more returned points. So let's go back over to our scene view so we can actually see what's going to be happening here. Now nothing is visibly different yet because all we've done is store the output of this near points function. But we're going to get into it very soon. Now we're going to want to actually know how many points were returned. So we can do another variable here, and we'll just use an integer. And we can say num points equals len, and now you'll see that returns the length of an array. So you just put our name in there, np, and now if you were to go back up here, you can see num points now has 5, 4, 3, 5, 5. That's just telling you how many points are actually in the near points array. That'll come in handy for us. Let's go back to our scene view. Now let's do a for loop here. We're going to do a little bit of code here. For. You should have been familiar with this from other lectures, but if you don't know what it is, I'll explain after I'm done typing it here. We're going to do int x is equal to 1, and then x is less than at num points. And then we do x plus plus clothing parentheses, and then hit enter and do our opening and closing curly braces. So if you've never seen this before, all this is going to do is say we're initializing this variable int x, and we're going to make it equal to 1. Most of the times you would make it equal to 0, but since we know we never want the 0 entry in this array, we don't need to start it at 0 because we're going to actually use the value of x to cycle through our array, and we never want 0, so we'll just start it at 1. And we're going to say while this x is less than the number of points that are in here, then it increments this x value, so it just adds 1 to it. And so let me show you what we can do now. We're going to use the addprim function here. And if you look what it says, it adds a primitive to the geometry. So we're going to do this style down here where we're going to give it a geohandle, a string type, and some points. So let's do 0. That is the incoming geometry. That's what we want to create this on. We're going to do a polyline. You have to pass this in as a string. So you have to encapsulate it with these little quotation marks. Now comma. And now our first point is just going to be our pt num. That's the current point we're on, and that will be a source point. And then you want to give it our endpoints, our np array here. And you want to use x. And now if we click off of this, you'll see what you get. You get these little star-like things. Now we're going to have to adjust these values because they're not really working great. So you can go up here and say 425. Now you see they look more star-like, but there's a lot of gaps here. So you could even change things up here like your seed. You might want to change the amount of these points here too. So now you see they get a lot more star-like because there's a lot more target points to choose from. So you would have to go back and forth and dial this in to whatever you want. But let's make this a little more interactive. Instead of having to hard code this in, we can do our little trick here to do a channel. So CH, and you could just put radius and click the little plus here, and you'll see it defaults to 0, so they all go away, but then you can just go like this and change it interactively. Makes it much easier. You might also want to limit the number of points, okay? There was a value that you could add into this to just give it, you know, a upper limit of how many points it can search through. So we could do the same thing, CH, and say, I guess max points. Doesn't matter what you call these things. It's whatever you want them to be. And again, they disappear because right now there's no points that it can return. Even on 1, you'll see nothing because then it's only going to be returning the source point. You won't see anything till we go at least till 2. And you can see something tiny happen down there. But you're going to want this to be much higher. This is the maximum number of points it's going to search through. And now you really wouldn't want this to ever be a fractional value. Not that it is a big deal, but you could always go up here, edit your parameter interface, and say max points, and just change it from float to an integer, and hit accept. Now it'll only be integer values. You might want to also change this maximum amount. It does default to a very low number, so we can edit again, max points, and change this to say 100. And now you can see you have much more of a range to pick through. Once again, this is giving us a little warning message, this little exclamation point, you know, it's complaining again about float to int. Something that really doesn't matter, but if you really wanted to get that to go away, you could do the little encapsulation trick here and typecast this away. Now you see the little squiggly line is gone and the warning message is gone. It's up to you. It doesn't make any bit of difference really if you leave it how it was. So that's just a very cool little quick thing you can do with a wrangle. There's other ways you could do this, but this is a very simple and quick, effective way of doing it in a fairly procedural manner, and it's great that you can just quickly change your seed here. Also, another thing to note, there's 2 ways you can make variables in Houdini in these wrangles, and I'll show you an alternate here. If you Alt and left drag this over, we could have just said, let's make this just an int, but it's going to break it. And obviously it all goes away because now we do not have the little symbol before this variable. We've kind of made this as a local variable that only exists in this wrangle. So you would then have to change this num points. You just remove it. And now it's back to working exactly as the other one. But you'll notice on this version, the one where we kept this little symbol, if we go up to our geometry spreadsheet, you can see the num points value here. If we look at this one, there is no num points value, okay? So you can't inspect the values of your attributes or your variables when you just create this local type of variable. Now, this is more efficient. Let's say you don't ever need to use the value that's in this variable once you get off of this wrangle node. You only need to use it in your wrangle. It's better to create it this way, just because you're creating more geometry overhead. Think about it, if you ever go to write out this data, if the points have dozens of extra attributes on them, it will have to store all that data on the point, and that can become very large. You could always go down to the bottom of your chain and do an attribute delete node. Once you're done with your rig, like over here, we could just say, okay, points, we don't need NP and we don't need num points. And if we look, we still get all of our cool stuff because that all happened up here. And then we just delete the data down at the bottom and we clean up the amount of data that's on these points. You can see now we only have 1 point attribute compared to having 3 up here. Just something to keep in mind. Most of the time when I'm trying to get a rig to work or trying to prototype something, I absolutely do this method because then you can go into your geometry spreadsheet and inspect the values to make sure it's actually getting the value that you expect. So that's just one thing to keep in mind. Let's go back to our scene view. Now, this is cool, but hey, it's on a flat surface, so let's actually make this a little more interesting and do it on a spherical surface. We can just drop a sphere. Let's look at it. Let's change this to a polygon and just change this to something like 10 so we'll get some nice faces here. Now let's just select this whole thing and Alt and left drag it over. And we can just swap these out. So now that the scatter is going to be on our sphere, you can see we still get scattered points and scattered points. This is one of the great things about Houdini, the procedural nature of it. You can prototype something on something like an easy flat grid. Once you have it working at that stage, then you can try it on a surface that's more complex, like a curved or spherical surface. Once you have it working there, then you can roll it out to an actual rig, like if you were trying to do something on a big set of geometry, like a ship or a character with complex surfaces. But you should always start easy just to get a proof of concept to make sure your idea is going to work. There's no reason to make it complicated in the very beginning stages. That might just make it take much longer for you to figure out how to fix it or make it work correctly. So I usually almost always start on a flat grid. So now we can do a couple things here. You can see it works by default, and it works pretty well actually. We can also do our little adjustment here on our global seed if you wanted to change the pattern. But if you notice, let's say we wanted these to be on the actual surface of this guy. So let's do a merge, and we have to spell it correctly. Merge. Plug the output in here and just grab the output of our sphere. And let's make sure nothing else is visible. All right, well, let's do one thing here to clean this up. So once we're done with this attribute wrangle, we no longer need all these additional points. So a simple node to get rid of them, you can just drop down an add node, go over to polygons and say remove unused points. And now you'll see all of the points that didn't get any type of polyline connected to them just disappear, they get deleted. It's a great, easy way to usually clean up geometry like that. So now you can see they're there, but they're very difficult to see because they're almost coinciding perfectly with the surface of that sphere. So we're going to want to do something about that. And what we can do is we can make them conform to this surface, but if you enable point number, right now you can see we have our center point, and if you look at something like this, a long one, there's no points in the center of this line or in between the beginning and the end. So you couldn't make this conform to the surface. You need more detail, more resolution. So you can just do a resample, pop that in there. Let's change this from maximum segment length. We're going to set an explicit count, and you can do something like, let's just do 30, that'll be enough. Let's disable our point numbers. You can enable just the points themselves if you want to see. Now we have way more point count, way more detail there. But we need to do something to make it stick to the surface. So another wrangle will come in handy. I'll show you another really cool function that works very well. So let's plug in our lines here into our first input. Let's get our sphere up here. Plug that into our second input. You can rewire this so that now the output of this attribute wrangle is going to go in and get merged. But we haven't done anything yet, so you won't see anything yet. So now let's just do something very simple. You hit @p equals min pose, and you just type 1 and @p. Now, did you see what happened there? It might have been hard to see, but let me disable and enable. See how it's flat? And now see how it's curved, flat, curved? This min pose expression here, function, is going to sample the distance to that surface, and then it just moves our points nice and easily over to it. If you look at the information here, min pose, it'll give you a little bit of information here. Given a position in world space, that is our P, and that is the P, the position of each point that we're working on. It returns the position of the closest point on a given geometry. So it's going to look here, we'll have to delete that. It's basically saying, let's template this. It looks at a point on this line, and then it looks for the closest position on this surface, and then it just moves our point to that surface point that's the closest position point. Okay, that should make sense, right? That's not difficult. So let's look at it. Now you can see they're much easier to see because they're right on the surface. But now maybe that's actually too close to the surface. It's literally on the exact surface position. So what if you wanted to offset these a little bit? Well, again, it's Houdini, so there's a number of ways you could do that. So let me show you a wrangle method, since we love wrangles. Change the wiring. You technically, well, you know, actually let's just do it all in one wrangle, why not? But we're going to need something additional here, some additional data. If you've watched some of my other previous attribute wrangle lectures, you might know how handy those normals are. So let's go up here and type in normal. We can just wire it in and just change all this wiring so everything's getting that normal. Doesn't really matter. And we'll switch it to points. Now you'll know we get our normals here. So that's great. Those normals will transfer to these points, and those normals will then therefore transfer to these points and these points. It all trickles down, so that's great. Let's disable this display though. And now we can say we can offset this position now a little bit by that normal. So we could just do something like plus at n. Now that's going to be a gigantic offset. You can see how much it offsets them, but you can see it's perfectly spherical. So you know that we can do something like multiply this by a smaller number and see how it sucks it all back in towards the surface. Again, that's probably way too much. If we just wanted to offset these slightly, you would probably want something very small like 0.02. But then if we look at our surface, you can see that's still too much. So you can see how this is kind of getting boring, having to go back and forth and constantly change this. So as you know, we can do ch and just type in offset or any name you choose, hit the plus, and now you can interactively change this and pick exactly what you want if you just want them to be a little off the surface. Now this is Houdini, and as always I usually like to show alternate methods of how to do something. So not that I again want to discourage anyone from using Wrangles, but if you drop down a peak node, we could have said, okay, now that we have normal data on this, you can use the peak node. And watch what happens. It just pops it right off the surface. Just like we're doing with our wrangle node here. But this is a non-coding way of doing it. But that drops down another node when you can do it all right here in one wrangle. So it's a good idea to just do it like this. You can build your own tools inside of a wrangle. You could technically also use the ray sop. If you've never seen this, I'll just show you real quick. Again, this is non-wrangle related, but ray points are primitives, so we can pick our points here, and then this is our collision primitive. Grab the output of that normals node and plug it in. You can see I'm disabling and enabling. You can see how it moves. So if you then, let's say we could do another merge. Merge, come on. Plug it in. Plug in the output of this normals node. And you can see you get the same thing essentially. And as well with this ray, you could do a lift here. If you wanted to lift it off the surface now, you see you get some funky stuff happening there in the core, but I'm pretty sure with the bias, you can try to fix it by using a negative bias. It actually seems to work. So as usual, there's many ways to get to the same end result in Houdini. There's the ray, there's the peak. I just like to do it all right here. It's very simple, very quick line of code, rather than have all these extra nodes. I'm going to delete this because this has nothing to do with Wrangles, so don't expect to see it in the final scene file. So that's all I'm going to show you for this quick little trick here. In the future, I'll actually show you maybe how to do something really cool with this, like have these things randomly growing on over the surface. That could be used to create some cool looking effects, but it's getting a little long in this video for a quick little video on Wrangles, so I'll show you that in another one. So I hope you like what you saw. If you did, you know what to do. You got to like and subscribe. That algorithm, that's going to downgrade you apparently if people don't like and subscribe, so click that button and stay tuned for more videos because they'll be popping up randomly. With that being said, that's the end of this lecture, and I'll see you in the next one.